Hi, my name is John McFetrich, and this video is on using JavaScript for writing applications. And JavaScript traditionally has been mostly labeled as a language for adding interactivity to web pages. However, in the last year, I've been working on a project where this team has implemented a very compelling user interface using JavaScript. Now, it's 50 to 60,000 lines of code, and in any language, when you're dealing with a project of this size, it becomes important to follow certain patterns and practices. And in JavaScript, this is particularly important. So I want to share with you some of these things, and we're going to start off with some object-oriented ideas. Now, I'm going to assume a certain background here. I'm going to assume that you are familiar with object-oriented concepts and acquired these in languages like C#, Java, Objective-C. It doesn't really matter. These object concepts have been around for a while, since probably '67. And the OO ideas that I'm going to be drilling down on are classes, objects, inheritance, and private and public properties. Now, I'm also going to assume that you have a certain level of knowledge with JavaScript, and this is not your first look at the language, because I'm going to be looking only at some fairly advanced topics, some review. So if it's your first experience with JavaScript, you might find this a little painful. JavaScript itself always runs in a host environment, and this can usually use the browser and a web app for web apps, and Node.js for creating server-side applications. It also can be used for creating rich cross-phone applications, in particular with HTML5 and CSS3. It makes a compelling solution here at particular platforms like SensuTouch and jQuery Mobile. Now, so JavaScript is not just a tool for adding simple interaction to a web page, because we're going to show it can build robust applications. However, I want to caution you, in the words of the foremost authority on JavaScript, which is Douglas Crawford, JavaScript is a sloppy language, but inside it there is an elegant, better language. And hopefully I can show you how to expose this elegant, better language using object-oriented techniques and to avoid the sloppy parts. Now, just want to review some OO concepts here, make sure we're all on the same page. In a classical language like Java, we have classes that are going to act as blueprints for objects. And for instance, here we're going to declare this class called point. And the point will have 2 ints as properties, and we'll have a method add. And add will just take 2 parameters and return the result. And this is a blueprint. This is not the object itself. So when we want to instantiate the object in memory, we use the new operator and we create a new instance of the class point. So point is an object, which is an instance of the class point. Well, now I want to show you that we can do much the same things in JavaScript. Hopefully this is nothing new. And with OO inheritance, our objects we build up our inheritance through classes. And in this case, point3D is going to inherit from the point class. And we're going to add some additional properties and methods. And just like we're going to new up this object the same way we did with our base class. Now, my objective is to show how we can do much the same thing in JavaScript, but of course without classes, because they do not exist in JavaScript. So first of all, as a review, just make sure we have some fundamentals nailed down here. JavaScript is an object-based language. In fact, everything is an object. And object is a fundamental type. And this object is a dynamic collection of properties, and which of course is different from C# or Java, where the object is a class instance. And each property has a key string. And of course, it's a dynamic language, and properties can be added anytime, not just at the definition time like in C#. However, we'll see there are ways to mitigate this with ES5, which is the latest version of JavaScript. Now, objects we can create with this just with our braces, so we can create an empty object with the opening and the closing braces. Now, I caution you, this is not quite as empty as it might appear to be, but more on that soon. Or we can create a new object called name, and it'll have two properties: first name, John, and last name, McFetrich, and function. Again, this should be old hat, just a review. And we can embed these objects. We can have flight, which has airline number, and then it has an embedded departure object that has city and gate properties. And so if I want to refer to gate, it's flight.departure.gate. And of course, that value will be 2. So functions, we just again for review, are first-class objects. And they can be defined as function declarations, which is much like we would do again in C#, or as anonymous functions, again, much like in C#. And we can refer to these. We can just sum3 becomes a reference to sum, and again, we can call it the same way as if we just referred to sum. These are first-class objects, so they can be passed to other functions. Now, I just want to make sure that we have the same understanding of this keyword, because it's not the same as in C# or Java, where this is the current instance of the class. Now, it's close, but it's not the same thing, because it's a reference to the object of invocation, which allows a method to know the object it is concerned with. And this, or expressed differently, this refers to the parent object in a function if the function is called as a property of the parent. Now, there's one more wrinkle here. If the function is used as a constructor function in conjunction with a new operator, and there'll be more on this soon, this is going to be set to the newly created object. Now, this one we're going to break into some code, and I find an excellent tool for this is the Google Chrome debugger. It's a WebKit-based tool, and so the experience will be almost the same with Safari. And it's all entirely written in JavaScript and CSS. And the first thing we will do, we're going to define this standalone function called speak. And speak will just take one parameter text, and it will then output the value of adjective to the console. So we'll run down to the call. Notice there's nothing to the left side of speak. So what is this at this point? If we jump in to our function, then we can see this is set to the window object because there was nothing to the left. There's nothing to the left here. So the context is the default Windows object. And of course, adjective is not defined, so we will not get a very meaningful result. So what we do is we're going to define a new object called Bill, and Bill will set, and we'll have an adjective set and equal to Bill, and we'll have a speak function, and so will Ted. But of course, the adjective will be Ted. And then we jump down and we call our speak in the context of Bill by just having Bill to the left of speak. We will see the result, a more pleasing result. And we jump in here again, and we will see that this is indeed set to the object bill, and adjective is defined as we expected. Now remember, we took a look at what a class is in C#, and the new operator, we were able to create new objects. Now we're going to closely show how we can mimic this behavior in JavaScript, but of course, there'll be no classes. We will use objects. And the way we do this is with constructor functions in the new operator. And there's nothing that makes a constructor function different from a regular JavaScript function. It's just an ordinary function that has logic needed to create a new object. It's not a special construct like it is in C#. And it expects to be used in conjunction with the new operator to construct objects. Now, it was put into the language to mimic what was done in these classical languages. And there was really, with ES5, there was really a more pure solution that was introduced in the language called object.create. And we will look at that a little later because it requires an understanding of something called prototype. So again, let's jump into our debugger for a closer look at how these constructors work. In here, we have a constructor function called point. And and as convention, we'll capitalize the first letter of the name. And we're just creating two properties, and we have this add function. Note, later on, we're going to move this, but for the time being, we'll leave it within this constructor. The first thing we do is we're going to use our constructor in conjunction with our new operator. So we have created an instance of our new point. And the point, instead of being a class, the point is just this constructor function, but much the same as we would do in C#, and we get the same result. Is that P1 is on the type point. So just as a review, at this point, as all as we've done, we've shown that we can take a class from C#, and this is our point class, and we can quite easily morph it into a JavaScript form using constructor functions. And when you look at the two of them, there's really not a huge difference, except for, of course, the visibility of this, which in the case of point, of course, this is the point object. And this is the object of invocation or the containing object. And then, as in both cases, in the case of C#, we're going to new up our point object from our class. And in JavaScript, we're going to again use a new operator in the constructor function to create our new P1 point. So now we're going to look at that step 2 in our OO, and that is inheritance. And remembering, of course, that inheritance in the classical language is using a class. I've done classes here. However, and this is really important that we wrap our mind around this, we have prototypes. All JavaScript objects have one additional attribute, and it's a pointer or a link to another object. And this object is called the object's prototype. And the whole idea is that if we try and look for a key on an object and is not found in that object, JavaScript will look for it in its prototype. And it'll follow this chain until it finds a null value for a prototype, which will occur on object. So if we're looking for a kind, and kind is not found in Zach, but Zach has its prototype, or its, I guess if we look classically, as the object it is derived from, and here it is person. In person, we don't have the kind, and we again continue along the chains, and we have the creature as a prototype to person. Oh, and we find kind in here, so kind is returned. So again, very important that you understand this, and that's why when we look at, remember back here when we defined a new object, and 01 it looks like an empty object. However, we can call the value of a function. And where did that come from? Well, it came from the prototype that is automatically assigned, which is object.prototype for our seemingly empty object. And if we look in the object, we will find we have a toString and a value of. So the seemingly empty object is not quite as empty as it seemed. And of course, we can override the value of with our own implementation. Now, we're going to use a prototype here to remember when we define point. And this, we can immediately start to use our knowledge of prototype in improving the architecture of our solution here. Here, remember at point, we had our add function right inside the constructor function. Well, we're going to move this into our prototype. And this way, the implementation is going to be shared between the objects that are created from point. And so when we create our P1 and P2, both of them are going to share this implementation of add. Now we finally reached a point where we can show how we implement inheritance. And inheritance here, of course, is going to be based upon prototype. And this is a little different from the way we would do it in a classical language. Remember that in languages like C# and Java, these classes were first formulated in '67, long time ago. I'm sure way before most of you were even thought of. And the prototype school came out of Xerox in the Smalltalk days 20 years later. And here we're going to base our inheritance will be based upon objects. And it's also referred to as differential inheritance. And when you make an object and you just add this stuff to make it different from the base object. So the new object only contains the difference. And every object in JavaScript has an __ proto property. And this is the object's prototype. However, it's a property that you shouldn't play with because it really is not part of the standard and the actual property itself. And so any code you write using this may in the future no longer work. So the code reuse is done not by making a class template, but by creating new objects directly. And the existing object is assigned as the prototype of the new object. And then new behavior can be added to that new object. Now at this point, I have to introduce kind of a nasty little part of this language. It's the function prototype. As I mentioned earlier, all objects have a prototype, and it is defined by the __ proto property. However, functions also have a function prototype property. And it's not the real __ proto property. It points to the objects that will be assigned as a prototype of instances created when that function is used with new. And if you want to see more details on this, I refer you to this URL. So now we're going to jump back into our debugger, and hopefully it will become clear that we can very closely mimic this the C# or the Java classical inheritance pattern, and where of course we are using classes, and in this case we have our point 3D, which is extending the point class, and we add new behavior to the class, not to the object, and we new up our subclass, which in this case we'll call point 3D. Now, we can do almost the same thing in JavaScript, and because in this case we will create our point or point 2D superclass, and it'll have the same properties, and it'll have an add function. And then we're going to create a subclass called point3D, and we're going to set its prototype to 2D. So point3D will use the prototype to inherit the capabilities of point. So we're now in our debug, back in the debugger, and the first thing we do is we define our point superclass. And using the course, it's a constructor function that'll return a point object when it's used with new. And then, because we want to share the behavior of our add function, we add to the prototype for point. Now, very importantly, we're going to set point3D's prototype. And this is key because remember, as I said earlier, only functions have this prototype property. And so we use to set the prototype for the new object. So point3D will inherit all the properties and the behavior of point. And we also want to add some new behavior to 3D. And again, we do it through our prototype. So now, if we use our debugger and we will look at what happens when we call our new, we jump into the constructor for 3D and notice that it immediately makes this call into points constructor so that we will set the properties of point will be set to 0, and then we will add our new behavior to our point3D. So now, if we run down here we can ask some questions. Is Q an instance of point? And the answer, if we look in our console, is true. And then if we ask, is point3D, is Q an instance of point3D, that is also true. So we can call the add. We can say Q dot add, and in this case we will call this the add method that was defined in the superclass. And then when we call add3D, we will call the add3D function that is defined in our subclass. So hopefully I've shown you using these patterns that you can do in inheritance in JavaScript, much the same as you've been used to doing in C# or Java. Now I'm going to show you another way of doing it, and we're going to use an object.create. Now this was introduced in ES5, and it's more, as I said earlier, it's more in tune with the real JavaScript way of doing things, and that is using prototype and not mimicking what the C# and Java languages do. However, it depends on your point of view. If you're more comfortable with using C# and you've been doing this for years, then you probably will prefer using constructor functions in new. But so just for completeness, I will show you the object.create, and here we've got a point object. And with object.create, this is actually should say point, and because we were going to use point as our prototype for point3D, and then for our point3D object, we can add our Z properties. So this looks like much the same as our earlier diagrams, but just like a different way of getting here is where point3D will derive from point2D. So back into our code to get a feel for how this works. Let's just run down further into my example. This inheritance is strictly based upon objects. We're going to be extending an existing object and without any constructor functions and no new operator. So I'm going to create my existing object point, and point I will have my properties and my add function, and then I'm going to call object.create then this point object becomes a prototype for my new point 3D. And then I'll add functionality to my point 3 object to differentiate it from point. So if we look at point 3D, it'll have the Z property, but it will still extend my point object. So the inheritance is strictly done using objects. Better taste, if you're more comfortable with the classical style, use it. Now let's take a look at another aspect of C# and Java most of us are used to using, and these are properties and accessors. In C#, we're able, in a class, we're able to define private and public members. And private just tells the compiler this is completely accessible only from within inside of the class. And so our field string here is declared as a private member. And then associated with it is a property. And it's how the outside world gets to it through two accessors. One is a getter, which is called whenever a property is read, and then we have a setter, which is called when the property value is set. So ES5 gave us capabilities to replicate much the same things in JavaScript. When it introduced the define property method on the object. And the object defined property will take 3 parameters: an object, a property, and a descriptor. Now remember, a normal property assignment will create a property that can be enumerated, changed, or deleted. And this is the part that we want to control, is that particularly we don't want to create these properties and later on have them changed or deleted. And this is the whole purpose here. So we have 2 types of these descriptors. One is a data, which will allow us to assign and control values, and the other are the accessors, which are our getters and setters. Now, the defined properties has keys. We have a configurable key, which applies both to the data descriptor and the accessor. And if true, the property can be deleted. By default, it's false, so the property cannot be deleted. And the data descriptor has a key that allows us to assign a value and to define whether that is writable. And then we have our accessors where we define our getters and setters. Now back into our debugger. Here, I just want to show how on normal operations we have a new object, and we can add properties test and save. And then, of course, we can delete these. So if we look at O, we'll see we only have high. It's probably not so great for long-term maintainability of code. So we can tighten things up by using our define property. And here, we're going to add this property A to O, and we're going to assign it a value of 37, but it's not going to be writable. So we've got a read-only property, and we can't delete it. So now we see that our A property is still there, and number 2, it is still has a value of 37. More into the things we can do in Java and C#. Now we're going to define another new object here, and we're going to show you how we do these getters and setters. So I just defined a new accessor property here, and I'm going to have my setter, which will be called when I assign a value, and my getter, which will be used when I get the value. So now when we try and set the value of new accessor property by assigning a value of 30, we're going to call into our setter, which we define with our define property. And also, if we try and retrieve the value, of course, we will call a getter. So much the same that we did in C#. Now, how do we take and apply this to existing objects? Well, look up here. We have an HTML tag, This is a heading. It's just a div. Now, I want to make some of the properties of the HTML element read-only. And the way I do this is I describe a new descriptor for the HTML element prototype and its member query selector. And assign it a value query. And then I say that it's not writable. And then I'm going to take and I'm going to associate this descriptor with that query selector property of the element prototype. So we've made query selector read only. Next, we retrieve this the HTML element from the DOM, which is this is my div, and then we try and change the query selector property. And we'll look, it's still query. We could not change it. Now we're going to do one more thing in this example. We're going to turn on the use strict mode. And this just makes the JavaScript environment less forgiving, which is a good thing when you're doing large applications, because you want as much as help from the environment as possible. In JavaScript, there is no type safety. And that's as we get in C# and Java. And I don't know, in my opinion, the more help we can get from our environment, the better. And turning on strict, we will get more help from JavaScript with errors. I should also mention that there is a movement to get some type safety in this language, and that is Microsoft's TypeScript. And it's a very interesting tool still under development, but I would stay tuned on that one. So we turned on our use strict, and then we'll go back down to our defined property, and then we would try to do our delete. Now we get an exception. So we're getting more help from the environment. So instead of having a silent error, this exception is being thrown. Now, namespaces, which are used in C# and Java, do not natively exist in JavaScript. However, they can be simulated. And because namespace collision is a big issue in JavaScript, because everything by default will be added to the Windows object and will become global. And it's so easy then to misuse or reuse the same variable name and not be aware of it. And JavaScript is not going to complain; it'll just merely use it. So the way we mitigate this is with object literals to simulate a namespace. So here we have pan, and we can introduce the two properties type and fry. So we can simulate the namespace pan, because now we refer to type as pan.type. So we're qualified in type with pan, and it's highly unlikely that pan is used somewhere else. And of course, we refer to this as pan.quantity. The slight downside, all these variables are public. However, we do have a way to mitigate this. And it's a thing called a self-executing anonymous function. Quite a little mouthful, but the way it works is that, notice these red braces. This makes the function immediately executed or self-executing, and of course it is an anonymous function. So if we look inside of here, we have a variable public and grease. And then to the public, we're going to add the ingredient property. So this will become a public property because we're going to return public. And so the public parts are going to be returned in the return. And grease, which is not part of our return object, is private to this function, and so cannot be accessed from the outside world. So again, the way we access it is through pan.ingredient, because pan is what is being returned by this function, and that is public. Again, we'll now we'll look at some code to hopefully make this clear. So just to give you more of a feel for these self-executing anonymous functions. I defined this really simple one here, which just the function will just pop out in alert, and the brackets make it automatically executed. Notice in this case it's not an anonymous; it's just a normal function, and but the same result is immediately run, and we see the alert. Now I've defined this pan object much in my slide, and it is a self-executing function, and it will have this private member grease and a public, in return public, and then we have our public property ingredient that is set in our public object. So this will be the return from pan. So the only thing that is accessible is the pan.ingredient. So this becomes my public property. And then if I try and access grease, of course, it's undefined. So that's the result we wanted.
We've reached the end. And dear, you're probably glad to get here. But I hope I've been able to show you that if you're an OO developer and you've been used to using these concepts in C# and Java, they do carry over into JavaScript. And if you employ these patterns, you can build very robust applications. I hope you enjoyed this.